Today we're going to talk about force vectors, and the very first thing we're going to do is we're going to talk about a scenario similar to this. The first thing you need to do whenever you're identifying a force vector is to identify the direction in which it is going. For example, force vector F is going 10 degrees counterclockwise from the positive x-axis. And what that means is the vector is referenced off the x-axis on the positive side and is rotating counterclockwise. Force vector H is rotating clockwise 52 degrees from the y-axis, or the positive y-axis. If I had not indicated which axis, positive or negative, that could lead to some confusion, because if I said it was 52 degrees from the y-axis, that could be right here, because I could do 52 degrees right here, still going clockwise. But this would be the negative y-axis, this would be the positive. That's the reason you need to identify whether it's positive or negative. You also need to consider sense. Now, sense is nothing more than restating the direction, but using it in common English terms. For example, this vector is going up and to the right, and when you go up and to the right, both the x and y are positive. This vector is going down and to the right. When you go down and to the right, x is positive, y is negative. Down and to the left, x and y are both negative. Up and to the left, x is negative, y is positive. To solve a force vector for its components, the very first thing that you would need to do is to divide the force vector, or to draw the force vector in isolation. For example, I'm going to do this force vector right here. To begin with, I draw the force vector in isolation. There's my force vector. It's 10 degrees. And it has a label of F, and it's 123 newtons. That's the force. Treat the force as if it's a length. The next thing that I do is I come in and I start labeling everything. Like I like to show my y and my x-axis. Since this is the axis that was referenced with the 10 degrees, I'm going to draw straight down and create a 90-degree angle there. That way I can use the trigonometric functions. This is the line that is opposite of my given angle. So this is opposite. This is adjacent. And this would be my hypotenuse. Since this line is parallel to the y-axis, this is going to represent the force of vector F in the y-axis. Since this adjacent is on the x-axis, this is going to represent the force of F in the x-axis. To be honest with you, typically we only use two of the trigonometric functions to solve for the sides of the triangle that we use for force vectors. And that's going to be sine and cosine. The easy way to determine which one you're going to use is to determine what you want to find first. In this case, I want to find force vector F. That's just a personal preference because ordered pairs x comma y with the Cartesian coordinate system, which is what we're based on. So I want to find force vector F. That's the adjacent, and I already have my hypotenuse. If you look, cosine, adjacent, hypotenuse. So I'm going to use the cosine feature for this one. So cosine of theta equals adjacent over hypotenuse. The next step is to start substituting in what I know. So the cosine of 10 degrees equals, adjacent is also known as f sub fx. So f of fx over my hypotenuse is 123 newtons. Now all I have to do is solve for s sub fx. To get s sub fx by itself, I multiply both sides times 123 newtons. These two cancel each other off, so I now have f sub fx equals 123 newtons times the cosine of 10 degrees. When you use a calculator, please make sure that the mode is in degrees. Typing this in, 123 times cosine of 10, that gives me 121.131, etc., etc., etc. I'm going to round to the closest tenth, this one decimal place. So in this case, my f sub fx is 121.1 newtons. Whenever you do these, please put a box around your final answer so it's easy to find. Since I've used cosine, I'm now going to use the sine feature. And that'll give me the opposite over hypotenuse. So the sine of theta equals opposite over hypotenuse. Okay, so the sine of 10 degrees equals s sub fy divided by 123 newtons. Solve for f sub fy. Multiply both sides times 123 newtons. These cancel each other out. So I have f sub fy equals 123 newtons times the sine of 10 degrees. Punch that in, 123 times the sine of 10, and you get 21.3587. Again, we're rounding to the closest tenth, so it's going to be 21.4 newtons. Again, box the answer so it's easy to find. Now, I'm going to go on to do the next force vector, because my ultimate goal is to actually combine this force and determine which way and with how much magnitude that vector is going. So, we start off by drawing this vector in isolation. So I have the vector going in the correct direction. It's 52 degrees. And then I come in and I start labeling everything. There's my x and y axis. Notice this time I draw back to the y-axis. The reason I drew back to the y-axis is our angle is referenced off the y-axis. This makes this my 90-degree angle right here. That means this is opposite, this is adjacent, this is hypotenuse. The hypotenuse in this case is h, and it equals 119 newtons. Since opposite is parallel to the x-axis, this is force of h in the x-axis, and this is on the y-axis, so this is force of H in the y-axis. Again, I go through the same process. Like I said, I always like to start with the F sub x, the x-axis. I have opposite and I have hypotenuse. Sine, opposite, hypotenuse. So the sine of theta equals opposite over hypotenuse. Start substituting. Sine of 52 degrees equals, opposite is F sub hx divided by 119 newtons, because that is the hypotenuse. Multiply both sides times 119 newtons. That gets rid of the 119 on the right hand side. So if I punch that into my calculator, I get 119 times the sine of 52 degrees, and I get 93.77. Again, we are rounding to the closest tenth. So in this case, it's F sub hx equals 93.8 newtons. Box my answer. And go to the next one. Since I use sine, I need to do cosine because I have adjacent and hypotenuse, adjacent and hypotenuse. So the cosine of theta equals adjacent over hypotenuse. So the cosine of 52 degrees equals adjacent is F sub hy divided by 119 newtons. Again, solve for the missing factor or the missing variable. We need to get rid of the 119 over here and put it over here, so we multiply both sides times 119 newtons. Those two cancel each other off, and I get F sub hy equals 119 newtons times the cosine of 52 degrees. If I type that into my calculator, I get 119 times cosine of 52, and that is going to be 73.26, which would be 73.3 newtons with our rounding. Now, what have we done? The only thing that we have actually done is come in and determine the direction of the forces in the vertical and the horizontal for each vector. Now we need to combine those so that we can find out the new vector and the new magnitude and the direction of the magnitude. To do that, what we're going to do is come in and we're going to add up the forces that we have. F sub fx, that was 121.1 newtons. F sub hx was 93.8. If I add those two together, 121.1 plus 93.8, I get 214.9. So 214.9 newtons. That's going to represent a new vector that I'm just going to label Fx. Or that's going to be the one component of a vector. Now that we have our forces in the x, we need to determine our forces in the y by doing the same thing. So force of Fy equals 21.4 newtons. Force of Hy equals 73.3 newtons. Add those two together, you get 94.7 newtons. So the force in the Y is that. Now, the very next step is now to come in and determine how big our magnitude is for the overall new vector. So I'm going to draw a y-axis here, and I'm going to draw an x-axis way out here because the x is a lot longer than the y. Let's go ahead and let's use a nice bright color and say this is our x, and it is 214.9 newtons. This is our y, which we're going to say is 94.7 newtons. So let's go ahead and label those. 214.9 and 94.7. Okay. Our new vector, if we draw from our start point here, that's our new vector. To determine the magnitude of that vector, I just use Pythagorean theorem. And I would say, let's go ahead and change the color, make it a little easier to see. We're going to say 214, and of course it's going to act that way, so 214.9 newtons squared plus 94.7 newtons squared. That gives us 55,150.1 newtons squared. We take the square root of that and we get 234.8 newtons. Remember, a squared plus b squared equals c squared. A squared, b squared, c squared. To find this, I just take the square root. The very, very next step that we need to do is come in and determine our angle. I'm deleting all this stuff off the screen so it's easier to see. That way I get a little bit more work room. That's supposed to be a 2. So, theta is going to be equal to the arctangent, or inverse tangent, of the opposite over the adjacent. This is the angle we're looking for here. So this would be opposite. This is adjacent. $94.7 divided by 214.9 newtons. These cancel each other off, and we punch that into the calculator and you will get 23.8 degrees. So here's our new magnitude and our new direction. The new direction would be 23.8 degrees counterclockwise from the positive x-axis.